So our last lesson with radicals, or square roots, has to do with rationalizing the denominator. So you can't have a square root in the denominator for an answer, just like you couldn't have a fraction or anything else. So we have to get rid of it. So what we have to do to get rid of it is multiply the top and the bottom by whatever square root is in the bottom. Okay, so 5 was in the bottom, so we have to multiply it by the square root of 5. So these are just fractions, so I want to go straight across the top. So one is outside, one is inside, so that's going to give me 2 square root 5. Because I can't put them together because they're not both underneath the square root. Then on the bottom, same thing, square root of 25. Okay, so let's simplify as much as we can. The 2 root 5 doesn't have any couples and pairs, but I know that the square root of 25 is 5. So now I need to look, do my outside numbers reduce? Is there anything that goes into 2 and 5? Nope. So this is my answer. All right, so then on the second one, same thing. I need to multiply the top and the bottom by whatever the bottom is. All right, so what I need to do then is I need to take 8 times 12, which gives me 96 inside the square root. And on the bottom, I get the square root of 144. Okay, so the square root of 96, I'm going to break down into couples and pairs to try and reduce this. So I know that 3 is going to go into it. So I'm going to do 3 and 32, which breaks down into 8 and 4, which breaks down into 2 and 4. Okay, so I have a couple of 4s, a single 2, and a single 3. So what that gives me up top is 4 square root 6. Now the bottom, what is beneficial of this is the reason that we do it is because the bottom is always going to be a perfect square root. So the square root of 144 is 12. It's 12 and 12, so that's a couple. So 12 goes to the bottom. So now I need to look at my outsides. Okay, I say 4 and 12. Is there anything that divides both of those? Well, 4 goes into both of them. 4 goes into 4 one time, and 4 goes into 12 3 times. So here's what I really have. I have the square root of 6 over 3. I don't want to reduce anything inside of the square root because I already did that. That was what couples and pairs were for. So I only want to work with the outside numbers. Okay, so now there's coefficients attached. But again, all you're trying to do is get rid of the square root itself. So just multiply by whatever the square root is. So the square root of 3 is my root. Okay, so what that gives me is the 4 on the outside, and then the square root of 12. On the bottom, I get 5 square root of 9. Okay, so in the top, let's go ahead and break that down into couples and pairs. 4 and 3, 2 and 2. So there's a couple of 2's to go outside here. So that's going to give me 8 square root of 3, because 3 is single. Then on the bottom, 9 breaks down to 3 and 3, or you just know that the square root of 9 is 3, and there's nothing left inside, because that's what we want. We want the square root to be gone. So that's going to give me over 15. Now I look at my outside numbers. Is there anything that divides both 8 and 15? Well, there's not, so my final answer is that. Okay, same thing over here. We're looking at what is the radical that's in the bottom. Well, 5. 5 is the radical in the bottom, so I want to multiply them both by 5. So my outside number is 3 times 1, so I just get 3. Inside, I get the square root of 20. On the bottom, I have the square root of 3, or I have 3 on the outside and 25 on the inside. Okay, so 20 can break down into couples and pairs to 4 and 5, 2 and 2. So I have a couple of 2's to go outside here. So that's going to give me 6 on the outside. I have a single 5 that stays inside. Then in the bottom, I know the square root of 25 is 5, which gives me 15. Okay, now I have to look and say, is there anything that multiplies 6 and 15? Well, there is. They're both divisible by 3. When I divide it by 3, I get 2 on top and 5 on the bottom. So I get 2 root 5 over 5 as my answer. Okay, a couple more just like this. The square root of 11 is what's in the bottom, so I need to multiply root 11 over root 11. Okay, so this has to go to both of these. It has to distribute to both. So I'm going to have negative 3 square root of 11 minus the square root of 55. On the bottom, I'm going to have the square root of 121. Okay, well, I know that 11 doesn't break down into any different couples and pairs, and 55 only breaks down to 5 and 11, so there's no couples. So the numerator is going to stay the same. But on the bottom, the whole reason we did this is to get this to 11 and 11, which is a couple. So here's what I now have. And I look to see if anything divides negative 3 or 11 or 1. Well, it doesn't, so this is my final answer. And it's okay to have a big answer. You just can't have any square roots in the bottom, is your only restrictions on this. Then our last one, square root of 7 over square root of 7. Same thing, I have to take this to both. So I have negative 2 square root of 7 plus the square root of 35. Then on the bottom, I have the square root of 49. Okay, well, 35 only breaks down into 7 and 5, so there's no couples to go with that. But 49, we know the square root of that is 7. So my answer is going to be 2 square root of 7 plus the square root of 35 all over 7. The end.